Hello, everyone. Welcome to another Fireside Chat with Encord. I'm very excited today to be joined by our guest, Dr. Victor Prisacariu. I will introduce him in a second. Briefly, I'm Eric, co-founder of Encord. Encord is a data engine for computer vision. We help companies, institutions, and individuals who are building computer vision models create, manage, and evaluate their training data. And today I'm joined by Dr. Victor Prisacariu. Victor is the principal investigator of the Active Vision Lab at Oxford University, where he has been for the last 15 years. In addition to working in research and publishing papers, he was the founder and CSO of 60 AI, which was sold to Niantic in 2020. He has since taken on the role of chief scientist at Niantic, where he works on a number of very interesting projects, which we shall get into today. I should also say Victor gave us very, very useful advice when we were originally starting our company. So we are forever indebted to getting things in the right direction from early on. So thank you, Victor, for joining us today.
Thank you for having me. And yeah, we've been chatting for many years now. It always feels shorter than it was.
That's true. Yeah, time flies by quickly, especially when you're in a startup. I wanted to start off today because you've been doing computer vision for a decade and a half, to just go over some longer term perspective. And I'm curious, given all the developments that have happened in the last decade or so, what would you have been most surprised by when you're originally starting working in computer vision? What would have been something that would have not been part of the original expectations that you had in the early days?
Obviously, generative AI, the magical new thing that everyone's talking about is quite amazing. But I'm going to try and select something that's not so obvious. And that is some of the stuff we've seen nowadays on sort of 3D mapping. I spend most of my time in one way or another around 3D mapping. And if I go back to the days of my early PhD, I remember my supervisor telling me if it works on one image, it's a master's. If it works on two, it's a PhD. And that was about the sort of 3D reconstruction and tracking we were doing. And stuff sort of worked, but you had to control the video. You couldn't move very quickly. The moment you moved a bit more, the whole thing failed. Reconstruction barely showed anything. Whereas nowadays you're looking at sort of world scale reconstructions with everything running in mobile phone in real time with all the semantic information and enabling stuff like generative AI later on. So all of those fancy things, and they're all running on mobile. It's a significant improvement from the sort of stuff we were doing back when I was a younger man in 2008 or 9.
What do you think was the development that most enabled this more general usage? Like, what was it? The amount of data availability, the kind of neural network architectures that came out, the way that people were looking at the problem? I'm curious, like, what really got us to where we are today compared to the beginning?
If I was to tag one thing, I'd say GPU compute. It's I was using CUDA back when CUDA was young in CUDA 2.0, and no one cared, but you could see stuff popping up. There was a thing about 2009 people detector called the HOG detector, histogram of oriented gradient. It's a long time ago, but when the first GPU version of that popped up, suddenly the possibilities opened up for people to do actual computer vision that sort of worked. HOG was one of the first things that worked, and in a sort of timely manner. So I really think the GPU is what makes everything possible. The mobile phone, you can have fancy compute, NPUs nowadays, of course, on neural nets run on GPU. But the fact that you can run compute in a sort of human time, and that human time could still be a week, but you can run compute in a time in which you don't forget what you're doing, is, I think, what enables stuff. Obviously, there's data, there is a lot of people working on it, there's public interest, there's company investment, but I would say that nothing would have worked without proper GPUs and proper programming pipelines for those GPUs.
Do you think there's still a lot of juice in just kind of pushing the computational boundaries? So just adding more compute, more GPUs, we can hit other kinds of benchmarks and break some other glass ceilings with respect to model performance? Or is there some saturation point?
I suspect we can still add more, though I think there's a lot more interest nowadays in doing things with less compute. for obvious reasons, cost, environmental reasons. But I think there's still probably room to improve the GPUs. If you look at the rate of increase in performance, there's a lot of room, I'm sure. Even if comparing the current generation with the one 3 ago or 4 ago, there's still a big speed up.
And you mentioned generative AI. So one of the other fireside chats I did, the guest mentioned that a great clickbait first question is, how does ChatGPT change everything? Whether it does or not, I'll put that out to you. How does ChatGPT change everything or anything?
Well, I can give an example from my day job, and that is education will change a lot. It's right now, it's fairly common in many disciplines to ask students things that you taught them. It's sort of the obvious thing to do. You taught them something, you ask them to say it back. But that's not going to hold in a few years. While examination ways will drag, at some point the student will have GPT, will have access to the entire knowledge of your course and everybody's courses within a couple of clicks or a couple of typos away. And they will have to come up with new things to improve ChatGPT, to improve on ChatGPT. There's literally a question I saw for an exam not long ago where the teacher said, this is the answer that ChatGPT gave. Surely you can improve on this. What is your answer to this question? So I think in sort of, my limited world of morning teaching, there's a huge impact just from ChatGPT. But of course, there are other things that companies do, translating stuff, but it's done nowadays. I've seen people translating sort of tech documents. That's something that's popping up, even aiding or helping, or maybe one day replace, but probably not replacing, but certainly helping with recruitment. That's something I've seen done. So there are these all sort of obvious applications, but much like my co-founder back at my startup used to say, there's a big gap between the initial applications and what actually ends up being truly successful, and you don't know what that is, because if you knew, you would build a thing that's truly successful. So now we're seeing the sort of V0 of the obvious places where you're going to put it. Yeah. And I suspect in 5 years, somebody will do something that we really have no idea, we really haven't thought about.
Yeah, the kind of innovations stack on each other. So it's very hard to extrapolate, because the things in 5 years will be built on things that we have like little imagination for in 3 years, which maybe we have some imagination for in 1 year, and then eventually gets to a place where, oh yeah, how do we get here? It was this kind of, everything logically made sense, but it's very hard for us to understand the future to that level. So maybe just on this point of education, because you are a professor, have you adjusted, like, are you going to adjust any of your strategies or the way that you think about classes or teaching students with ChatGPT? Is this a concern for you, or is it kind of, going forward and just hoping, hoping there's not too much of a disruption with respect to how you're teaching?
My hope is that we should adjust. And it goes at all sorts of levels. I have PhD students, I have master students. I would very much expect PhD students now to have much better writing. They can ask ChatGPT for help. And it's sort of like an Uber proofreader, but nevertheless, it is help. I would expect them potentially to come up with literature reviews quicker. Obviously, there is stuff. ChatGPT might be hallucinating things. You can't fully trust everything they say, but nevertheless, I would expect them to use it now, and I'm encouraging them to use it now. I suspect it will sort of slowly trickle down into undergrad teaching. It will probably take a bit longer because stuff moves a bit slower there. But I would still expect, realistically, a few years from now, we should adapt. The students have access to this already. And arguably, they had access to Google, and going back in the past. So some of these things they could have shared, but now they have very easy access to stuff. And I really hope that we do use it. I would not be surprised if there's a world in which you have access to ChatGPT during your exam and you have to answer your question. At least that's the world I would like to see. There are many complications beyond this, proper internet connection, people's ability to type very quickly, and so on. But I certainly see in a world in which you have access to all of these and you have to solve your problem.
Yeah, I think that a lot of people are looking at the risks and disadvantage within the kind of educational frame, at least, of ChatGPT for students. But there's equivalent, like a huge opportunity, because now you have your professor essentially on a terminal all the time that you can ask it questions, and students can probably figure out their own ways to learn things that can go back and forth with ChatGPT. So I think there's some potential for actually like speeding up the way that learning happens and different educational facilities. But it's about kind of understanding, okay, what infrastructure and what other things do we need built around it to make that happen. Yeah, that's quite interesting. So you're currently a professor at Oxford. You also have had a career as an entrepreneur and now a chief scientist at Niantic. I'm really curious about your journey first as an entrepreneur. So founding 6D AI, what that process was like, how you balance it against your responsibilities at Oxford and doing research, and just the kind of general journey that you had with the startup before it was acquired.
So I started working on sort of 3D reconstruction or dense 3D reconstruction a long time ago. I'm going to say 2012, but number might be incorrect. And I started working on this sort of pipeline or framework that I called at the time Infinitam. And it was built very much with production in mind. It doesn't mean I knew how to do production, but the aim was I wanted to have code that's expandable, that's easy to build, because at the time there was no code that you could do that. You could not go online and download the library for doing 3D reconstruction and expect it to work. It wouldn't. That's evolved a lot since, but back then there was no such thing. So I started with this practical idea of let's build something that's easy to build, easy to use, easy to plug in, easy to expand, that can run on multiple devices, that can compile on Linux. It was a magical thing at the time if you wanted to compile on Linux and on Windows, and you couldn't do it. So we built that, and it wasn't just me; it was a bunch of extra people. They're all pop up on the Infinitam org maintainers list, and we got some traction with it. People liked it, and at some point it was like, okay, we want to make this used by more people. So how does one do that? Well, my thought was that one would do that by sort of booting up a startup that would see as its mission getting this sort of technology in people's hands, in developers' hands, and getting these used by everyone. Being the sort of, I remember telling my co-founder before he was my co-founder that my aim is for this to be the default standard that everyone builds their experiences and AR and 3D reconstruction on. So I was presenting this stuff around. I was doing live demos at times, and I was at this company that I won't name, and I was doing a presentation about the work, and I ran into somebody who says, "Oh, we run this VC group in San Francisco. This sounds interesting. If you're ever around, come visit us." It was Super Ventures. Then later on, I happened to be an area chair at CDPR. It was nearby. I flew to San Francisco. I went to Super Venture. I did the demo. I said, "Look, I have this magical stuff. Here is how it works on my tablet, and here's how the people making a competitor software. I mean, I wouldn't call it competitor since this was just an SDK, but here is the solution that's available now, and here is my thing." And it was a very clear difference at the time. So one of the VCs was Matt Biesnix, and he effectively decided to quit his job and start a startup with me, which was nice, and that was clearly a good pitch.
I've never seen a pitch that good where the VC actually comes to the other side of the table and then goes. So that must have been like a really, really good one.
It took us some discussion, and it took us a whole year after that to sort of iterate on what we want to do. At some point, we want to do headsets. So how does one expose that technology? Eventually, we converged on this sort of SDK or collection of APIs that developers can build stuff on. And we were also a bit lucky that ARKit popped up at a similar time, so that removed the uncertainty of tracking. Tracking is very difficult. I have deep respect for the people who build trackers that work. Apple, Google, Magically, Daiquiri. They build things that actually work, and tracking is very difficult. It always fails. Anyway, so people build these trackers. They were starting to be available in commodity devices. So then we said, okay, the uncertainty in tracking is gone. Now we can build this thing. We still needed depth images at the time, so that was a thing. But we said, now it's time to spin up the company. There's still the uncertainty in depth images. But if we remove that, if we manage to remove the fact that you need a depth camera to build these 3D reconstructions, we're actually going to have a viable framework that can do sort of 3D mapping, stuff for like occlusions, for meshing. We had ideas of how to start connecting them in what Matt at the time, my co-founder, used to call AR Cloud. And we booted up the company. We were quite successful earlier on. I mean, we were successful with our initial pitch. People liked us. ARKit had just happened, and we could say, look, we're going to build the next thing. We got funding from General Catalyst at the time, which was one of the brighter VCs in the Bay Area, and we ended up spinning out and building a company. The first thing we had to work on was removing the depth camera. We managed to do that, and we had a period of miracles, I would say. It was the most wonderful time in 6D, because every other day the entire team was shocked by how big the progress was. Because we knew a couple of things. We had read on stuff. We had worked with people. We knew what we were going to build. But and then we hired a bunch of amazing people that joined us, me and Matt. And I remember at some point, somebody that I had worked in the lab and then joined 6D made a couple of changes to the method. And it went from this sort of frame rate style depth mapper that basically built a depth image here, depth image here, depth image here, to effectively a smooth, continuous experience that looked like you had a depth camera. So we built a bunch of magical things. Now, of course, having a nice SDK at the time, and it had its own problems. The walls weren't very well reconstructed and so on. The range was limited, so there are big problems. But then we started trying to find developers or people who would use this, and we went all the way up to a couple of thousand developers with this. I think people liked our stuff. I want to hope it worked well. We also had a relocalization module, which at the time was effectively just trying to find your position of one user scanning relative to the other user. Somebody does a scan, somebody does a scan somewhere else. They see each other. They build up this sort of collaborative mapping effort, so they both get to map the world. But then at some point we had to decide: do we go A? Do we switch to do we go to the next stage, or do we join somebody else with a similar vision? And luckily at the time, Niantic had a similar vision, and they still do. They very much saw the world the same way we did. They wanted to build this map of the world. They wanted to scale our technology. There were differences in how we do it. We were a device-first company. We wanted to do everything on device with both the good and the bad that entails. Some of the bad being the fact that if you accidentally switch, or if you upgrade your descriptors, you have to invalidate all the maps you've built, which is great if you're a startup with a couple of users. It's not great if you have 1 million users and deploy products. Niantic was more cloud first. But basically, we found ourselves, I would say. So, and we continued the adventure in building the Niantic map, as it was called, or as it is called now. Niantic Map is the sort of project of mapping the world. And at its core, the very basic part is the VPS. That's the bit I've been working over the last few years, the visual positioning system. That allows you to sort of take your camera, go to a location, take your phone out, point it at the world, and find a hopefully this level of accuracy position. You'd hope in 10, 20 centimeters, something like that, and maybe a degree or two. We called it Niantic positioning, the visual positioning system, but of course there's more to the world than just that.
Was this part of the, so is this a continuation of the trajectory that you had at 6D, like having a visual positioning system, or was this taking the technology that you were building and applying it into this particular application? Was this already kind of in your mental model, like where things could go, or did that come with the conversation that happened with Niantic, or what after you joined?
We both wanted the same thing. I think that's sort of why the acquisition went so smoothly, is that we had this in mind. I had a grant proposal many years ago where my proposal was users can map the world. I had assumed they had depth cameras. They can have semantics, they can have functional semantics, what I called at the time, all of those things. And Niantic wanted exactly the same thing. After we were acquired, it was funny that whenever we chat, it's like, I have slides from like 5 years ago, what do you exactly this? So it was, we very much wanted the same thing. There were some differences, as I said. 6D was device first,
Yeah.
Whereas Niantic was let's build the cloud version first, and that doesn't necessarily mean Niantic will always be cloud first, but at the time it allowed us to iterate better and modify stuff and improve our algorithms. Some of the methods did go straight into the Niantic DPS. I think the first version of the Niantic DPS was using 6D algorithms. The first versions, the first successful localizations, and for a while we stuck to 6D algorithms. The reconstruction went in a more interesting place. We basically our second week in Niantic, somebody popped up with a set of slides saying, this is how I think we could merge what Niantic has with what 6D has in terms of depth estimate. And we're like, okay, sounds great. Worked fine. We ended up within a couple of months with the thing already deployed and working within what turned out to be nowadays Paradox. It's a game that Niantic released not long ago, and it's running the much more evolved version of what we had done in the first days. But it is a sort of the grandson or grandchild of the 6D depth is now running in Paradox. And a similar version of that is running in building 3D maps in the cloud.
How did you get to the point of having these conversations in the first place with respect to either an acquisition or maybe with respect to vision? Did you, were you already in some kind of partnership or collaboration at the time, or did you come up to them and say, oh, this is what we're doing? Is this interesting to you? Or was it the other way around? How did these things kind of develop?
If I was to remember the point, I think the first time Matt said, "Oh, we got a call with John Hankey from Niantic." I don't know exactly how Matt did the thing because he was in San Francisco, I was in Oxford. He was managing this part more. I was more on the technology side, but it was at some point somebody arranged a call, and it sort of up and down went from there.
And so you kind of went through as the chief scientist in Niantic. One very maybe silly question is, what is a chief scientist? So functionally, like what do you do? What are the responsibilities? And how do those differ from those of a CTO? So, how would you and the Niantic CTO have different areas within the company that you're focused on?
And Niantic is even more interesting because we also have a chief research scientist.
Okay, so all right, so chief scientist, chief research scientist, technology. How do you guys see the world with
the way I see myself is I think I'm closer to an applied scientist. I care about the science behind things that go into product within a horizon of maybe 2 years. That doesn't mean the horizon always is 2 years. That doesn't mean everything goes into product. That doesn't mean we don't publish. But if I was to sort of give a baseline, I'd say I will. My favorite type of research is the one that takes an idea that is just possible and takes it all the way to an algorithm that will run in product. There is another team that will do all the deployments and the minutiae of we work a lot with them, but there's like a build team and so on that will take that and build it all the way to the product. And there's also within Niantic, I don't do the sort of things that are on a horizon of more than 2 years, maybe. Or even 1.5. Within the university, we do things that are far away and impossible. But within Niantic, I'm much more of an applied scientist. Our CTO is also a co-founder. He's done a lot way beyond my tiny little corner of the world. Whereas our chief research scientist is running a research lab, who's also, these things blend. They will also do production work, but I think their mission tends to be closer to publication and further away research. That being said, again, they do practical stuff, we do research stuff. It all sort of mingles.
Yeah, so this is a very kind of auspicious time to have this chat because you guys just released this map relocalization. I'm very curious to learn more about it. Also, where did that sit? Was that originally in the research, and now it's applied research, and then now it's getting deployed? What is the kind of trajectory of that project as you've been working on it?
Some 2.5 years ago, we were looking at building the Niantic visual positioning system, And at the time, we had a bunch of approaches. One was grandfather from 6D, one Niantic had, and one we said, let's try something more exotic. Let's try the state-of-the-art in neural network-based localization. The neural network one worked really well, better than the other ones. So after that point, the 6D one was the worst, which, funny enough, it slowly died out. But after that point, we sort of continued with these competing, well, not competing necessarily, but these two separate pipelines. I did a blog article a while ago where I call one the crazy path and one the safe path. And this is sort of the first time I'm actually able to talk about the crazy path because we just published the stuff. So the safe path was sort of a standard system. Standard pipeline. It doesn't mean the components are necessarily standard. There's neural networks in there, but following a more standard sort of extract features, build a 3D map, localize relative to a point cloud 3D map. Challenges there included stuff like productionization, quality of codes, tuning parameters, because parameters in these things, and so on. The other side was the neural net, and the neural net we had a system that was okay. Within some limitations and within some requirements, it liked depth maps more than it should have. It took 12 to 14 hours to train a single sort of map, to build a single map. And I should say that the way we built our VPS in Niantic is that we have right now mapped a couple of 100,000 locations in the world, about 200,000. And each of them might have up to 100 different scans from 100 different users, each of them needing at some point a map. So there's a lot of maps to build.
Is this it sounds like a problem that would be very conducive to synthetic data. If you create a representation, you can take all the synthetic views of it. Is that part of the strategy for training?
There is an effort. Certainly one can use synthetic data to do things. In our case, the data was we had our users helped us. There are certain ways in Ingress and Pokemon Go where you can upload a scan of a place of a way spot to our server. So we have these many sort of short scans, about 10 to 15 seconds of a place. They go through anonymization, through privacy scrubbing, where they mask our face, license plate, so that the data tends to be as anonymous as we can make it. And then it goes into these mapping pipelines where you have to build maps, millions and millions of maps.
And is the kind of labeling of this automatically done given the positions, the metadata that comes through the phone itself, or is there?
That's where it gets interesting. It depends on the type of data you want to extract. There are bits that will require manual labeling. We have a system that builds semantic information. It is now deployed, and you would see it in Peridot on device. There is a version that runs in the cloud as well, and that will tell you what stuff is. And that one goes through a more standard sort of labeling pipeline and a bunch of network architectures that I can't detail, but there's plenty of manual labeling there. On the reconstruction side, it gets mixed. The neural nets tend to be, or the localization neural nets tend to be sort of self-supervised because you have to recover the pose, and you can use the pose as supervision information. You have an image and you have the position of that, the pose of the camera, and you can use that to train things. And depth, in fact, Niantic's, our chief research scientist and his team developed a self-supervised way for training depth. So that was some of the more magical stuff they did in the past. It was a system called monodepth, and then it evolved monodepth v2, simple recon nowadays. So there you end up with a mixture of data, both self-supervised in certain scenarios and sort of more, I don't necessarily say manually labeled because it's still depth, you don't manually label depth, but with ground truth data. So it's really a whole collection, a whole array of training data or no training data, self-supervision, unsupervision, and so on.
And by training these models on the 100,000 sites, you're able to outperform these other feature-based mapping algorithms by a good amount, by a little bit, by,
It's funnily enough, both methods compete with each other. So there's not, I like to say that we always move the worst method. So that it is when one of the methods starts better, that should be the worst we do. All the other ones should be. So right now they're actually not far off each other. the more traditional pipeline, but of course we've ingested more neural networks into it, more fancy features, matchers, and so on. But the neural network side, the key thing there, and that's still important, I think, is first of all, the neural networks are small. We can train them very quickly. That's the main thing that we are sort of releasing today when we release the source code, is the fact that you can train one of these networks in 5 minutes. Before, you would have had to have waited 12 or 15 hours. Now you can do it in 5 minutes, and it's as accurate. So, and it's 5 megabytes rather than 15. So it's smaller and quicker to train. So that sometimes, depending on the size of the world, that could be smaller than a point cloud. It certainly was smaller than point cloud a while ago, but our point clouds have been getting smaller, as I said. The two methods sort of keep moving. The other point that's interesting with this approach is that it's also a continuous process. You get a map after 30 seconds, you get the map after 1 minute, you get a map after 5 minutes. Each of these are sort of good. So sometimes you might have this sort of continuous way of, it's good enough at this point, I'm going to start using it, which a standard approach doesn't have anywhere near as easily. The third point, and I think this might turn out to be quite valuable in the future, or not necessarily valuable as much as useful and important, is that it's a lot more difficult to invert a neural network than a point cloud. I would argue that our methods are essentially private. Now, I don't want to say something is one way or another, because there's always somebody smarter who can prove me wrong. But at this point, you need the input image in order to produce a result. You don't have that input image, you don't have that result. It's not the point cloud, it sort of goes the other way around. So there is a sort of implicit privacy preserving component to our neural nets.
Why is that important in this context?
Back at XD and at Niantic, we very much care about that. And most of Niantic data, of course, is all public at this point, where it all runs on Niantic wastepots. But it's still nice to know that if one did need to map a private place, the technology will be there to a good standard.
And where do you see people taking the applications? Do you see them mapping their own internal rooms, their homes, just the kind of public places that they see around? Is there a collaborative aspect to kind of sharing the shared position in the world? How do you see people kind of using the technology for the different types of applications that they might care about?
Most of the usage will be through some sort of application, at least I suspect in the near future. Though that being said, Niantic has a wonderful scanning app called Scaniverse that builds very nice 3D reconstructions that I tend to scan things and show around. But I still see that us working more with developers than direct users of the technology. And these developers are building applications. Well, one of them being, for example, the Peridot thing that we saw. There are a couple of other things in the pipeline where users can go somewhere and experience something that is sort of unique to that location. There are a bunch of different applications. It's a bit difficult to go into specific. A lot of them are out, and I'm not entirely sure which ones are out. So, but
it's out there. Yeah,
I can see a world in which you go somewhere. Maybe that's a private space, maybe it's a place you scan yourself and then you can interact with it, or invite somebody, or somebody comes in your room and you're able to sort of share a 3D map and look at the same virtual world. I can also see it a place in which you go into a market, you go into a square somewhere, you have a statue, you can all look at that, you can interact with some sort of experience, potentially one of our games, potentially one game's built on our platform. Indeed, other people are building similar technologies. So I think it will be an interesting system because it's inherently social, which is very different from sort of VR, which is inherently isolating, I think.
Yes. Yeah, I wanted to ask about that as well. Just kind of your thoughts on the metaverse and how this interacts, or if not, with any of the things that you're working with in the AR world, if there is a complete exclusion zone there, or if there's some area of intersection.
My gut feeling on metaverse is that it will slowly move into an AR concept. Of course, now it's seen more of as an extension of VR. Obviously, that can live on, and it's beyond my expertise. As I said, more intelligent people are working on it than I am. That being said, I think ultimately it will move into a layer over the real world, or at least a version of the metaverse will be a layer over the real world, where you can go somewhere, you can get information quickly from where you are, where the closest restaurant is, whatever. You meet your friends, you can both interact with a digital environment that is built on top of the real world. I can see this as a reason for people to go out. That's one of the things that sort of drew us to Niantic, where we say that we have a similar mission. People will go out, meet themselves in a real world place, potentially interact with through the virtual world. So it's going to look very weird if somebody doesn't have the headset or the phone to interact with this.
Yeah. Do you imagine people doing this through the glasses or headsets or phones, and that you're both communicating on, you're kind of communicating on two separate channels, one the physical channel and the other the virtual channel, maybe at the same time, with people in your own proximity? Is that kind of...
I'm sure that will happen. It's if I go back to 10 years ago, 15 years ago, if you saw somebody wearing Bluetooth headsets and talking to themselves, it felt very strange. Nowadays, it's a perfectly acceptable practice.
Right.
That you will not be surprised. So I suspect when people start using these technologies, it will look strange. When you have two people looking at each other and gesturing in midair, or indeed two people looking with a phone and running after some imaginary Pokemon. If you see that, it will look strange. In a couple of years, I suspect it will be acceptable. And as people start joining these experiences, they'll see they're fun, they're helpful. You don't stay and lock yourself and ruin your eyes in front of a tiny display. You go out, experience the world, meet people. This is just an extra layer on top.
So what do you think this enables? Is it that people will spend less time, I mean, kind of as you alluded to now, on their laptops and their phones, and bring that experience back into the real world? Or will this enable some other type of functionality or communication that maybe we haven't considered yet? What, like, in your imagination, how do you see this actually looking in like 5-10 years 10 years time?
That's a good question, because it can go either way. Some people, I suspect, will end up using the device less, using the phone less. I think about myself, I always have 1 or 2 or 3 mobile phones with me. That doesn't mean that I'm, and potentially a laptop, but I'm actually probably far less disconnected than other people, in the sense that I will use it for 5 minutes, I'll put it back. I will always have it with me, so the possibility is always there. But because I can do everything on my phone, I tend to go out more. It gets a bit weird because I do have my calls while walking outside, but it's certainly not been something that has kept me in or kept me glued to the mobile phone. That being said, there are plenty of people who, because they have the mobile phone, they're actually spending more time looking at the social media and so on. So, which is obviously not inherently bad, but different. So you see that on the one hand, this might mean that you spend less computer time and potentially have the technology with you. So you control the technology rather than have the sort of the schedule, for example, the Zoom schedule control you. On the other hand, it might just mean that you spend more time locked in the world. And for all we know, we might find ourselves in 10 years that people like to turn off the AR component and go into a full VR world. And you live in Ready Player One. So I don't know.
Interesting. Yeah, so maybe like VR is too ambitious for where we are now, and what you're kind of proposing is that the metaverse merges with the regular universe first, and then maybe over time one component kind of dominates the other.
My hope is that, or the way I would use it, is a layer over the real world, in which the ultimate destination is a real world that you interact with, that you live in, augmented with things to make your life easier and more interesting. But that doesn't necessarily mean it will go like that. I would not be surprised if it goes Ready Player One. Ultimately, as I said about the mat example, where we have no idea what people will build on top of it.
Yeah, no, that's really fascinating. And one thing that we're seeing now, just kind of generally, and it goes back to like the top where we're talking about generative AI, but now we're seeing some of these foundation models coming out in the computer vision space, the segment anything model from Meta. Do you see that there can be a foundation model that might be applied within the AR world? Or do you see any of the kind of like similar developments that would be relevant for this kind of use case?
I think AR will ultimately be semantic, and I think that's a very important stage. When you look, I have this sort of hierarchy in my mind, or pyramid of needs. It's not really a pyramid of needs, but pyramid of features. Let's call it like that. When the lowest level is a stable AR tracking session, that's sort of the base AR kit, AR core. Others have done that. It's good enough. It's very good compared to the stuff I grew up with. It's magical. So you have a working system that you can build things on top. Then you have dense geometry. I would argue that we had a hand in solving it. There are many others that have worked on this. But that allows you to sort of have a dense geometric understanding of the world. You know the surfaces that are around you. You know your position relative to those. Potentially, you can have somebody join in your world through a positioning system of some sort. Now, above that, you start to get with simple semantics, where you know something is road, you know something is tree. You can use that in some sort of way. You can have like we have in Peridot, you have the Peridot interact one way with flowers and one way with grass, and one way with a sofa and one way with water. That's already going to a much more semantically meaningful experience. I would see a world in which we go beyond that all the way to procedural behavior that sort of you'd know which surfaces are able to sit on, which surfaces are able to hide on. So that will hopefully expand the way the interaction between the virtual things you're using in your world, in your AR world and the real world. It will make it look much more natural. Like if you think of a dog, for example, you know, your dog will be able to sit on grass, will be able to sit on a broken table, will be able to sit on the table, will be able to sit on the chair. Whereas moving into this sort of segment anything thing will allow us to do some of that, but we probably have to explicitly say that the dog can sit on the chair. I can see a world, my hope is that it will go even further than that, so that interactions will look much more real on top of this sort of entire stack of good semantics, good geometry, good tracking.
And so basically that these models will match the human cognitive ability for our ability to understand and navigate the world in three-dimensional space. A model.
That's what I hope. Yes, that's what I hope. And I suspect it will happen, whether we do it or somebody else. I suspect it will happen.
And what is the time scale that you're thinking that this, semantic ability unlocked within the AR visual world will be out?
That's an interesting question as well, because it depends on ultimately how people access the world. At this point, people access the AR world through their mobile phones. That leads to experiences that tend to be more constrained because of battery, because of the weirdness of holding the phone all the time. Your hands get tired. So that means that you use it for a couple of minutes and sort of that's it. That's not really going to induce the giant roadmap. I suspect, even though you can build it, it will not live. It will not be alive. It will not change constantly. You're not going to have lots of users contributing into it. I suspect the moment you end up with AR headsets walked outside, this will inevitably happen within a year or two. It might happen before. I think it will naturally grow the moment people use it.
So there's a hardware dependency in this. I
think there's a hardware dependency, and it's even UX dependency. I remember that when we had early prototypes at 6T for building depth reconstructions, they were amazing. And I said, look, I can walk. And I walked, and after like 15 minutes, my hands were really tired. So you couldn't really walk. There was an actual human limitation. When I started my PhD, I wanted to do hand tracking. I love this Minority Report videos, and I wanted to do the same thing. It was amazing stuff. And then I did an early prototype. Now, nothing as fancy as what people do today, but it was sort of working. And I got tired after about 5 minutes. That says both something about my fitness level and about the fact that the technology itself is not very practical. So I think that sort of applies nowadays to some of the AR. You can build these experiences. You can have sort of localized, interact with it 5 minutes, 10 minutes. After that, you'll start getting tired. The phone will start to warm up. Simply running an AR session, an AR tracking session will have a measurable impact on battery after 10, 15 minutes. So I suspect that we're still hardware locked.
Yeah, it'll probably be unlocked by some niche or some narrower application that will enable people to start wearing the things and normalize it, and then slowly grow horizontally over time. Maybe if you're jogging, you want to jog in pretend a dinosaur is chasing you, and you'll run faster, and it'll be good for your exercise. And so there's an external reason to validate the use of the technology, and then people see the things with the headsets. Oh, I want to use this for this thing, and over time, more people will start to kind of adopt this type of technology, and then you'll get better data, and you'll be able to improve the models as well. Who knows?
The map will live. That's the main thing. You want a map that sort of changes lives, that reflects the real world that is there right now, and what is socially want people to be able to join. But that implies people using it all the time, and then we're not there yet.
Yeah, that's very, very fascinating. I mean, it's, we talked at the beginning, like, what will the future look like? And it's very hard to imagine it even now, 5 years out, with the pace of development that's going on in AI. And if you start to meld that together with how we experience the real world, then things can look very, very different, very, very quickly. And so it must be quite exciting to be part of that as you're working as the chief scientist at Niantic. I wanted to leave some time for questions that we got. We got a few questions from the audience. So I'll start with Gustan's question here. So I think this is some of what we touched upon. What are your thoughts on the latest trends that have been happening with segment anything models and how they can improve AR and computer vision applications? We touched on that a bit. He had a second question. Where do you see wearable AR technologies will go in the next 5 to 10 years from now? We also touched on a bit, maybe kind of summarizing the 2 points there.
And I love segment anything. I think it's great. I think we're going to have to build up on top of it. I think right now it's a wonderful, it's the new definition of low-level processing. Back in the day, low-level processing was extracting edges with no meaning. Now you can extract things that have meaning. But nevertheless, it's still, there needs to be a layer on top of functionality and all the way up to sort of semantic, procedural interaction. And so when you go to AR. Headsets, I'm hoping in 10 years we'll all be wearing one. I'm hoping it won't be too intrusive. I hope the battery will last long. And I'm hoping it will just augment our lives rather than replace them. Now 5 years, I don't know. 5 years, it depends on certainly 2-3 years. I suspect you'll end up with indoor experiences that will probably be very good, but you'll end up with sort of limited indoor experiences, this sort of pass through closer to VR experience. So my vision is closer to there's this computer game from Sony. I'm remembering the character, but not the game. The character is Aloy. I forgot the name of the game. Anyway, it's they have these devices that you put, and they can augment the world. And computer interfaces disappeared because you interact with the VR system. You can get information that's relevant to where you are when you are there. You can go and see the menu directly pop up on the thing in the restaurant. Doesn't mean you won't go to the restaurant. Maybe it means you'll go to more restaurants. So I'm hoping that's the future I personally would enjoy living in.
All right, ubiquitous headsets in 10 years. You've heard it here first. I think the application I would really love is not to have to look at my phone when I'm in Google Maps. I'm kind of looking back and down and just, go here, and end up at my destination. Okay, so the next question is on this bit, actually. In addition to visual control points, do you also use existing 3D mapping data from Google Earth or Street View for enhanced precision and accuracy? If so, what resolution of 3D maps do you use, if any, for localization?
We've built our own 3D maps. At this point, it's entirely internal. We're building them out of the user data, and it's like, as I said, it's a process that goes from either standard 3D geometry building 3D point clouds, or the magical neural net that learns things. Some details of resolution, like our error is somewhere between 5 and 20 centimeters, sort of like this big. So that's the sort of spatial resolution you get things in. Our map, I think, is built in I'm going to say 2.6 centimeters chunks. So the entire world that we're mapping is made out of voxels about that, but the number is a floating number. It can change. So, but we're not yet linking to Google or other system like OpenStreetMaps and Street View. That being said, the latest version of our system, which will sort of shortly pop up, what I call sort of VPS v2 or 1, depending how you start counting, will end up being georeferenced. So there, you should be able to with some degree of accuracy, depending on how the user scanned, you will be able to draw it on OpenStreetMap and Google Maps and get the buildings around you. One big difference between our VPS and others is that our VPS is built out of user data. That is both good and bad. It's good because we have fresher data, more timely updates. It is bad because not everyone, including myself, can film like a professional street view capture with a LiDAR.
Noisy, yeah.
Exactly, meaning that our accuracy tends to be a bit subject to the data we have, our GPS or correction, accurate errors, or our geo-positioning error depend as well on how many how many users, how long the users have walked, and how good the algorithms are, but also the sort of size of the data we have. So there are a bunch of different parts there, but yeah, those are some numbers of resolution. Hopefully,
okay, yeah, interesting. So another question: how will the recent advancements in AI help AR to make progress in the market? So we talked a little bit about this, but maybe emphasizing on the market aspect of the question. Does it get closer to realization and in a kind of commercial sense?
To some extent, but I still think we're hardware bound. I think generative AI is going to be great at creating more interesting experiences, potentially scripting actions, or potentially replacing the real world sort of on the fly of generative AI ran quickly with some sort of augmentation in a realistic looking way. But ultimately, I suspect we're still hardware bound more than creativity bound.
Okay. And last question from the audience, philosophy around full experience versus minimum AR experience on the platform, considerations around enabling opt-in versus default to full AR.
And this is my personal preference. It's not in any way the Niantic policy or anything like that. My personal experience is closer to minimum than the full. I see AR as augmenting the world, not replacing it. But that's just me. I'm fairly certain that my kid would at time love to replace his world with living in an Ultraman universe, and that would be great for him, and perfectly reasonable sort of desire. So I think we should have the choice. We should not be locked in one way or the other. I would not buy a system that locks me in a full VR world. I mean, maybe I'd buy it, but I certainly wouldn't use it all day if I was to be stuck. And on the other hand, if there is the possibility of switching, of turning on, closing the blinds, that would be important for certain experiences. That it could very well be that you find yourself on a train and want to listen to a concert, and you don't really want the whole thing projected on the chairs around you. So I suspect, I would hope there will be choice. And importantly, I would hope that this gets left to the users and to the developers. I would not be surprised if it will end up in a world in which it's like the rotation of the phone. You end up with some experience, some app providing an experience that applies, that maps to the real world, but then you can turn off the blinds and see something else. Like you rotate your phone and the thing changes. I would hope it's going to be on an app by app basis rather than enforced on us. But technology change moves differently. It could very well be that the first experience are much more closed off than it was. We're going to be technology bound, I suspect, more than development or API or whoever does these things policy bound.
Right. I think that makes a lot of sense. And certainly having the choice would definitely be my personal preference as well, if I was to kind of adopt the technology. Well, thanks. That's all the questions from the audience. Is there anything else that you want to share or announce, that maybe in relation to your release or anything else in the last minute or so?
Oh, we've had a bunch of releases. Play our games, they're nice. And if you're into building giant training neural network in 5 minutes, I think the ACE system is interesting.
Excellent. Well, yeah, thank you so much, Victor, for the time and also for all the conversations through the years. As I said, you were very helpful giving us really practical advice in the early days of the company, which has stuck with us. to today. And so really appreciate the time that you took for the chat. And I know things are quite busy, especially with all the releases and CBPR coming out. So really appreciate it.
Thank you very much for having me. It's great chatting.
Excellent. Well, yeah, thank you everyone for joining. Please watch out for a session that we have coming up with a semantic search of visual data using CLIP and generative AI. So I'll end it here and have a good rest of the day.